full disclosure, I haven't looked at them. Like, I literally looked at them 5 seconds ago and just quickly scrolled through them. So I don't know a whole lot of context, but one of the big pieces of context that stands out right away, I don't trust this. 35 points right there. It's the same as the unit quizzes. The unit quizzes were 40 points. So I don't know what that means. I just don't want you to see that and go, oh, okay, whatever. I'll get you more information about the final exam. We'll talk a little bit about it in a little bit. But first, because it was going to be on the screen, I wanted to at least address that. So that is very, very questionable. Everything else is true. It is an hour and 50 minutes. Our exam, lucky you, is scheduled for Monday. I think that's May 5th. And you ready for the exciting part? That is 7 a.m. to 8:50 a.m. So 1 hour, 50 minutes to complete it. You're going to need to get here early. Sorry. Yeah. So with that, I'll go ahead and pause that. So again, your final exam should cover units 1 through 4. Again, we didn't really discuss that, but it should cover all 4 units. My prep or recommendation would be to go back and look at each of those 4 unit quizzes and find things that you think showed up kind of commonly throughout all of them. That's going to be your first kind of most important path, because if it shows up continuously, that's probably something that was highly valued, and that's probably something that's going to show up on the final quiz. So see if you can find those connections first, then double back to each unit quiz and say, which one do you think is the most important kind of question? Do you feel it showed up kind of again and again, that content area? Identify that one per unit quiz, and that's where I would start. Okay, why would I start there? Because as a faculty member, that's exactly where I would start. Okay, I would go back to my unit quizzes and say, which one of these questions covered the content that I thought was the most valuable or the most useful? I want to make sure students know that content before they leave my class. So I'm going to double down on it and make sure that they see that again on the final. Provide that evidence that you've done it. Make sense? After that review of those highlighted questions, I would go back and review all the questions, because just because you think it's important doesn't mean the instructor did as well. Okay. As far as the format goes, I swear I looked at it, but I just started to look at it again and everything looked really different to me this time. So maybe I didn't look at it. I thought it had 5 questions on it. Again, I could be wrong, but I think it had 5 main questions with, again, the parts just like before. Okay. You do get an hour and 50 minutes, so it's a little bit longer, which makes sense because you get more time. The points for it, it says it's the same as the unit quiz. 35 points was not your unit quiz points. So I'm really confused by that part, but this could just be a rollover issue from past semesters that she's since made changes on. So where I would start is looking at the syllabus and see what the syllabus says point value should be. Right? Would not be surprised at all if it's the same as your unit quizzes, just consistency-wise. Personally, that's not where I would go, but that's consistency that seems to match what she's done so far. To the open note, that is something I'm going to have to clarify on. For sure, you're going to, I guess I shouldn't say for sure, but I would very much be inclined to believe you are allowed notes. Okay, the question is how much notes. I've got to figure that out. Okay, so I'm going to have to press on that. Even if it was fully open note, that is a horrible idea. Do not do that, please, for the love of God. That is a really bad idea. Okay, what you should be doing is going through and reviewing your individual note sheets, okay, and call attention to things that you felt were super valuable. Pull those things out onto a super sheet, if you will. Okay, as you have more space, you can backfill in more space. Kind of makes sense? That should be condensing it down to a single sheet of notes, okay, which may seem like, well, if we're allowed all my notes, that's not useful. It is absolutely useful because it helps set you up with a review so that you know what content's going to be particularly relevant and necessary moving forwards. So even if you're allowed more notes, I think that makes a whole lot of sense to try and condense what you've already got. Okay, it should provide a decent study process. You are allowed a calculator, 2 calculators. This is something that I'm going to be a little bit more insistent on, and by a little bit more actually insistent on. If you're using Desmos, it needs to be Desmos test mode. Okay, it does show that at the top. I will be walking around and checking. So if it does not say test mode on it, you will be interrupted during your final quiz to get that figured out. Okay, if you don't know how to get Desmos test mode onto your calculator or how it functions, talk to me. And I can help you get that figured out. You'll be given a periodic table and an equation sheet per usual. Okay? An equation sheet per usual sounds kind of interesting to me as well because I, again, don't think you should have equation sheets, and I think that reared its head in the last quiz for the relationship between pH and what? The H plus concentration. Didn't even cross my mind as a thing until someone in the Thursday exam was like, I don't know how to solve for H plus from pH. And I went, oh crap. Nobody asked in your class, so I'm not convinced, or I don't know if that was a problem for you all. But for sure, enough people voiced their opinions on Thursday that it was a problem for them. Okay, that's why I think you should memorize equations, particularly ones that get used again and again and again. Okay, so for the record, P anything. Let's take P of Mike. That sounds a little gross. P of Mike is the log of the concentration of Mike. That P is the negative log every time. So pKa, negative log of the Ka. pH, the negative log of the H plus. pOH, the negative log of the OH. Right? That's that equation. As many times as pH has shown up, and pKa's for that matter, has shown up off the last 2 quizzes, I would argue you should really know that, because I would bet it's going to show up again. Okay? Just as my kind of 2 cents and observations on what I saw. Kind of makes sense? So I will review the final exam before the next class, or the final quiz before the next class, just to make sure there isn't anything glaringly problematic. I'll also review with Dr. Schneblin to decide what's going on with those open notes. Okay, so that we've got that resolved so you're better prepared to launch into the final quiz next Monday. Okay. In that review, I'm not going to be sharing out what questions there are or what content areas. Okay. That's not my job. My job is to point out kind of the logistics behind the exam, and that's it. Make sense? Okay. So slightly different than any other week this semester. This week is largely 100% review, 100%. It's review. So that review can be based off of your opinions, or it can be based off of what slides we've got. I'm fine either direction. What do you all want to do? Live. Not that question yet. Backtrack. Quiz 4. If you want to retake that, up to next Thursday. All right. So that technically gives you time after you take your final quiz. But I think that's the only way to actually open that up and give you time to actually review both for the final quiz and for the retake. Okay? I will be on campus next week from, I think, 9, technically earlier than that, but not available before that, 9 to 4:30. I think officially I've posted 9 to 4. But I will be in final exams for large sections of that as well. Okay? That's not super useful for your test prep for the final quiz, but when it comes to the retake, right, you just gotta let me know. Because I'll be in taking or giving final quizzes or in office hours, I don't know exactly where I'll be, so that's why you're gonna need to confirm with me next week if you wanna retake a final quiz. retake quiz 4, sorry. Okay. Now, doubling back to the first question, what do you have questions on? Semiconductors from the quiz. Because in theory, you all have the quiz in front of you. I won't take pictures of somebody else's stuff because their work will show up with it. I can't record this. I can't record going over the actual quiz because now it's a permanent record. I can't record it, I can talk about it. Does that make sense? Okay. So, sorry for the recording. Some tips from Dr. Schneblin for studying for the final exam. So we'll review some of the major concepts across today and Wednesday. Outside of class, you've got your homework problems, and by homework problems, I would argue she means Alex. It is Alex, yes, Alex. And not only that, Alex does have a review feature. If you haven't discovered that, let's try it this way. Has everybody discovered that? Yeah? Okay, cool. If no, talk to one of your classmates, because I have no idea where it is. But there is a review function so that you could go back through and target your weaker concepts. So there's a map that describes how you've been doing within it. So getting perfects on your homework or high scores on your homework doesn't mean you learned it. It just means you've seen the content. So what you'd have to do is double back and prove that you've learned it through doing more practice to kind of reinforce that. Okay. So you've got those homework problems. You also have all of your quizzes. And if you've done the retakes, you've got the retakes as well. So you should be referencing, all of those quizzes to help prepare for the final quiz/exam. Right? And if you want feedback, sit down and talk with me to work your way through where mistakes were made and how to fix those things in the future. You need to identify individually by going through your quizzes to decide where you have weaknesses and try and fix those weaknesses. You've got learning materials within Canvas, objectives, lecture slides, the Alex homework, practice problems for each unit, all those kind of fun things. Okay, when you go through and do your practice problems, don't look at the answers first. Okay? I would argue you should never be given the answers because I'm a jerk. Okay? The whole point of looking at answers is to prove that you're right. So I fully understand that. But if you're getting it wrong, why did you get it wrong? And if you're reverse engineering how the answer was solved, you didn't actually figure out how to solve it. You figured out how to answer one question that you will likely never see again. That's not learning the content. That's not useful, and that's a pain. Okay? All that does is hamper your learning. This is why what I would argue you should do is not look at answer keys, but instead talk to someone who can pick apart your work and ask you questions about the actions that you made. That someone, yes, that's why I'm here. Okay? I have no problems doing that and going through all of the nitpicky details to ensure that you're okay within that. Practice explaining your answers, how you solve the problem, and what the answer means. So this becomes one of those things where you need someone to pick apart your work and your process. Okay? That doesn't have to be me. That could theoretically be our tutors in the tutoring center. It could also probably more appropriately be your fellow classmates, okay? Because they have misconceptions just as much as you do. So if you try to explain something and they're like, nah, I don't get it, you now have to resolve how to figure that out, okay? And that could mean talking to each other to figure it out. That could mean bringing in another party to solve it, right? Write things down in that process and organize your notes. Anything you stumble across as you're going through and doing things, dang, I wish I knew that piece of information because that would have helped me solve this faster. That should be going on a blank sheet of paper of what I would argue is memorized, but you don't have to memorize it. You just have to make sure that's your critical note sheet for the quiz. Make sense? Questions? Nothing, huh? Okay. So units 1 through 4, unit 1 talked about kinetics, unit 2 was thermodynamics, unit 3 was acid-base chemistry, and unit 4 was our electrochemistry. So this is the big summaries that she's providing behind these. So let's try a real quick twist. Okay. What was kinetics about? How do we quantify speed? It was a horribly vague question, but that's partly the point. What was that?
Is it activation energy?
Okay, cool. So activation energy is tied to speed. Activation energy is going to control this. Okay. How do you define your activation energy?
Rate equals like K times concentration.
Okay. Your activation energy is rate equals capital K.
No. Lowercase.
K equals lowercase times
Concentrations.
concentration of what?
X and Y, I guess. Whatever like your reactant made out of.
There we go. That's what I wanted to hear. Of our reactants. Okay. So in answering one question, I got a different answer. In answering the other question, I got yet another answer. How do we quantify speed? Activation energy controls our speed. Okay. And we can see how visually in a little bit. Okay. When I asked you to define activation energy, I then got the definition for speed, which was rate equals our rate constant times the concentration of our reactants. Okay? And there's multiple reactants, you got multiple things tied into that, right? Okay? You also have what to be concerned about when looking at that rate law? Pointing upwards, I accept that. Okay. You're looking at the orders, the superscripts that come with this. Remember, those superscripts are something you have to solve from an individual experiment. Okay? So that is experimentally determined. Or how? Say again?
Linear.
Linear is experimental. You're looking at experimental data that's showing a plot. So you can look at different plots to generate that. You can also look at other ways experimentally to do that. There's two ways to determine the order, experimental and literature is the answer, that doesn't count. Mechanism. So you could go through and define, this is the mechanism for how this reaction works. Once you've defined the mechanism, you can now define your orders. So there's two approaches. Okay? Just because you defined the mechanism, does that mean you're correct? No. The mechanism is a theory, it's a guess. Experimental is an actual determination of the order. It's the reality. The mechanism is our theory to hopefully get there. Ideally, our theory matches the experimental, but it doesn't always, which means our theory sucked. Try again. Okay? We talk about our activation energy. Where is our activation energy? Where does the activation energy appear? Cool, on a graph? What kind of graph are you talking? There's a couple different graphs that we could look at. One I really like, the other one I don't like so much. But cool. I'll accept that. Our reaction coordinate, where we're looking at progressing from reactant to product. If we look at the energy of our reactant to that peak, the peak is not the activation energy. The peak is the transition state. The activation energy is the difference between the reactant and the transition state. Okay, that's our activation energy. That becomes a challenging thing to go through and quantify off of the graph, which is where we get another A word that doesn't end in whole. The Arrhenius expression.
Oh yeah, that exists.
Yeah, that's about as far as I got too. Anybody remember it?
Equals AE to the negative EA over RT.
You're totally cheating, aren't you?
I'm cheating.
Yeah, that's what I thought.
I'm prepared.
That's good. And that would be one of those things that I'd be like, oh, dang, I don't have that memorized. I want to put that on a note sheet to make sure I've got that. Okay? So those might be some of the big kind of aspects that we might want to be able to nail down. So we need to know what rate constant is. We need to know we're dealing with orders, our reactants. The orders are determined experimentally or by mechanism. We're looking at an energy diagram as we progress from reactant to product. The transition state is the difference in energy between our reactant and our transition state. Make sense? Okay. Do you feel this is useful to go through and try and pull out whatever little tidbits that you remember about these, or should we just go into practice problems?
No, I like this. I forgot about all of it.
Let's just do practice problems.
Okay. Okay, so the two of you are fighting over this. You're at the same table. So anybody else want to contribute? Practice problems? Okay. Okay, I would highly recommend that you do something like this. Look at each of these topics and try and pull whatever information you can out of it. Okay? Ideally, if you do that first, before you start into practice problems, you can now look at a practice problem and say, where does this match to? Okay, what are the pieces of information I need to pull from that previous content? So there's lots of different environmental issues and just scientific issues in general that we could go through and address. So in looking at a practice problem, Dr. Schneblin is extra concerned about climate change, and so is looking at a lot of the different things that contribute to how we could potentially solve or fix this. And within that context, we now have hydrogen fuel cells. So this, reviewing a little bit earlier, this was our more recent stuff. Okay, so write the overall balanced redox reaction and calculate the cell, okay, or the cell potential. What is being oxidized and what is being reduced in the reaction? Use oxidation numbers, which is a fancy way of saying, as part of this question, what are you going to be expected to identify? What your oxidation numbers are. Okay? And if you're being asked to identify oxidation numbers, what do you have to identify the oxidation number for? This kind of reviews for quiz 4 practice. If you're being asked to identify oxidation numbers, you are doing it for every single element, period. Okay? And element, not complex ions, elements. So start putting it together, see what you come up with. We're going to write out the overall balanced redox reaction. What do we need to do?
Flip one.
We need to flip an equation. Okay? This was a common mistake that I noted in people's, or several people's quizzes. And one of the things that I identified that you should try and do is identify where your arrow is and note where your electrons are located. Typically what you're given are reduction potentials. By identifying those arrows and where those electrons are, you can note that you need to flip an equation so that the electrons cancel out. Remember, electrons are not stable. They must cancel. So if we're going to go through and deal with this equation, which one do we want to flip? The top one or the bottom one?
Top one.
We want to flip the top one. Why should we flip the top one?
It's a battery or like fuel cell, so you want it to be a positive instead.
It's a battery or fuel cell, which then means we want a positive cell potential. So we're going to flip the top equation. Whoops. And leave the bottom equation alone, because if we did so, we would set up the system for H plus, where we would have our E cell unflipped 1.23, and our E cell flipped would be the negative of whatever it was. It was already 0, so we didn't need to stress about that one. And we try and figure out our total cell potential. All we have to do is add those two numbers up. 0 plus 1.23. We want a positive value because it's a voltaic cell, and the voltaic cell we want to generate positive potentials. Okay? Common mistake found on the quizzes. Okay? When I went through and showed it, this is the process I have always shown. Okay? We flip. Okay? When we flip, we change the sign on it. What I saw a lot of people trying to do for the E-cell was I'm going to screw it up, the anode minus the cathode. Did I actually do it right? Is that the right formula? Oh, wow, look at that. Okay, a lot of people tried to do this formula and the process I showed. No. Okay, the whole point of writing it out this way is it already tells you which one to flip. This cell formula potential, okay, ignores the chemistry. The process that we went through and did shows the chemistry. You can't do both. You pick one and you're done. That's how it runs. Okay? Why do I not like this formula? I don't remember which one to subtract from the other. Okay? On top of which, I also then have to know what's the anode and what's the cathode. Does that say what one's the anode or the cathode? No. Does the question ask me to figure out which one's the anode or the cathode? No. So to use this formula, I have to do more work. You ask me, that's a bad idea. I'm not going to touch that. Okay? You have to decide as the student where you're at within that line. And if you're used to just plugging in formulas, that's where you're going to run into problems, which is why you're going to get things wrong. Understand the chemistry behind what's going on, and you should navigate a little bit better. So again, don't use that formula, my 2 cents. Come on, pencil, work with me. Okay? If we added these two equations together, would we get a proper overall equation? No, why not? The electrons must cancel through this process. And if we highlight or note the electrons, we're looking at needing 4 electrons to do the black reaction and producing only 2 in the red reaction, which means to balance this, I have to take that into consideration. I'm going to have to run that reaction 2 times. So now when I add it up, I'm going to get 2 H2s plus my O2 plus my 4H plus. The electrons, being on opposite sides of the equation and now showing up the same, will cancel, so I don't have to worry about those. This is going to set me up with my 4H plus my H2O. Yes, I multiplied that top equation. I don't have to multiply it by the cell potential. Again, I don't have a good explanation for why that is, but we don't do it. Did I do some math wrong?
Wouldn't you have 2H2 for your product? Because in the original expression for the
Yeah. I also just see another mistake. So thank you for pointing that one out, because I saw the other mistake. Okay, so from the original question, it was 2H2O. So I goofed on that. We should have that extra 2 down there. Okay, this becomes one of the problems of copying the equations over. Okay. The other issue that we need to watch out for is what else shows up the same on both sides of the equation.
4H bonds.
The 4H plus, which then means my equation is going to be 2H2 plus O2 goes to 2H2O. Make sense? Okay, so we've got our balanced redox reaction. Calculate the cell, we've got that. What's being oxidized and what's being reduced. It does say to go through and use the oxidation numbers, which means we should go through and officially assign. So we can take a look at the H2 in our starting material. Okay, I got a lot of people going through and doing a variety of things. A lot of people saying, oh, it was +1 because hydrogen's +1. Hydrogen is typically a +1 in compounds. Where we've got to be careful about is that there's always exceptions to that. And it's not so much an exception because you're making it a rule to make it +1. That's not the rule. Okay? What we would evaluate is that there's 2 hydrogens in that formula times an unknown oxidation number, which must equal the overall charge written in the upper right-hand corner. Since there's nothing there, it's a 0, which means the oxidation number for my hydrogen is 0. We could go through and look at the oxygen. Same deal. 2 times X equals overall charge of 0, which means my X equals 0. We now move over to the last one and trying to piece this one together. Okay, we have 2 times X plus, do I have a new color? Yeah. 1 times Y equals 0. That's 2 variables. with one equation. How do we solve?
Do you know why it's always negative 2? Or almost always.
Okay, that's what I was going to double back on. Our oxygen is -2 when it's bonded to anything other than oxygen or fluorine. Because it's being bonded to hydrogen, we're good with it being a -2. 2x minus 2 equals 0, and I'll get x equals +1. So if we're looking at my changes, I'm going from a 0 to a +1 for my hydrogen, which means it
Oxidized. Or
lost electrons, and loss of electrons is oxidation, which means what was being oxidized? Hydrogen. If we go through and look at the other one, we're looking at X going into that Y. What happened? It gained electrons, and therefore it was reduced. Okay? We've now identified our oxidation states. We also identified now all the pieces of the question, and we should be good. Do we have questions within that? Yes?
The oxidation number for hydrogen in the H2O, I thought it would have been +2.
So if we look at our overall formula system for how we'd go through and solve, okay, how many times does hydrogen show up in H2O? Shows up twice, which is that 2, times the oxidation number, plus the number of times oxygen shows up once, times its oxidation number equals 0. Okay? So if we lean into that formula process, that'll help us out. Okay? Again, what I think a lot of people went through and did was said that for the hydrogen to balance out the oxygen, hydrogen had to contribute a +2. That's true. That's not its oxidation number. Okay? Its oxidation number was a +1. There were 2 hydrogens. So the overall charge contribution was a +2 from hydrogen. That's not the oxidation number. That's an entirely different question. A question that, for the record, is never asked. Okay? Kind of makes sense? And when we look at more complex formulas, it becomes easier to fall into that trap. We don't care about charge contribution. We care about its overall oxidation number. Okay? Can I delete everything? Okay. So, why is this reaction so good? If we're going to talk about so good, I don't know where I was going with that. Predict whether the reaction is exothermic or endothermic, and predict whether the entropy increases or decreases. To increase the odds that you actually talk to each other and actually start to write things down, let's get some blood flowing. We've got numbers up around the board. Oh, don't flip that table. Those numbers 1 through 9 correspond to the tables that you are at. I don't care what your number is. Find a board, start writing some stuff down to answer this question.